I was a little bit,
Maybe it's because I'm an undergraduate
I
that I'm not there.
should be. Let me check after this. What about the last time? This is the second time to call attendance, right? First time?
Yeah.
I did. It's a DM. Oh, okay. I never used this one. I did one time in the DM. Looks like good. I can check the face also. Some of the students upload. Okay, so right after the class, why don't you check yours and check your campus where you are. Okay. Okay, so I was a little bit in a hurry to cover the topic. Usually I didn't have enough time to cover all the topic for this class. So this semester I was in a hurry. So because of that, I think that we can reasonably cover the most of the topic. So quickly remind what we are talking about. Using the very basic diagram of the computer system and the database. So what is this one? This is our computer. Okay? So computer has the important component like the memory, this RAM, we will discuss more later. Okay? And also we have the storage. Like this one, they are connected through the bus. Okay, this is our computer. And also they have the network connection. So nowadays the most popular one is TCP/IP. And then, so when we install the database management system, such as Oracle Information, MySQL, even though you are using the GCP is based on the virtual machine. The image of your operating system is running on the remote side. Then no matter what type of the operating system you have, you can install on your DBMS system on top of your operating system. Let's say that we are installing the MySQL. Okay. So first we need to start the MySQL, any database. So what does that mean, starting the DBMS? Start. Each DBMS has a functionality to start the DBMS system. So probably your manager asks you, why don't you check whether database is running, or why don't you start if down, or why don't you shut down the database system? What does that mean, to start the database management system? Even though each DBMS provides a different functionality or command to start your system, the database system, so when you start the database system, there are two parts. One is starting process, number of processes. Okay, same as the web server, web application server. If you start the Apache web server, or if you start the IIS web server, application server, you start what? The process. That process is doing what? Listening the request of the client. Then, when you receive the request, what happens next? You need to process the request. Like for example, in case of the web service, it requests an index.html file. Then this process listens, then this process is going to what? Check that document, index.html file. Read that. Sometimes this process is based on the threading. So you can fork. You can create another thread. Sometimes you can create another process. That process is working for the request client. Then check the index.html file and return to the client using the network. It's exactly the same thing. The DBMS system, when you start the DBMS, you start the process. This time, not only just listening the request, okay, but also doing a lot of job, like writing the data, and read the data, and the optimizer, and the management, transaction management. There are a lot of jobs. Sometimes one process doing everything, or number of process, but they are identical, like the threading, or sometimes the DBMS specify the specific purpose. Like for example, the Oracle database used a number of processes. One is for database writer. That is writing only the data to the database system, the file system, or the location, or log writer, as we have discussed last time, and also I'm going to introduce one more time. Log data will be the written, so this is a job. And then listening, just listen the request, like that. Plus, the starting the process, plus the next job is memory allocation. So, database use a lot the memory. So one, speed purpose, performance purpose. So everything, even not only data in the cache, but also the SQL and the log data. A lot of things will be in the memory as a cache purpose. Okay, so this is the starting. So you can start your database system. Then nowadays, the most of the DBMS support to listen the request. They have based on the client and server, the environment. For example, we can use the most popular, the network protocol is the TCP/IP. So using the TCP/IP from the client to your computer, then you can connect to your database server. It's exactly the same mechanism as the web application and web server. Okay, from the browser you can connect through the HTTP, the protocol, which is based on the TCP/IP. The port number is 80. Similarly, each DBMS use the same protocol with the IP and the port number. So each DBMS use a specific port number. Okay, it's not well-known port number nowadays. Even such a database port number are considered as a well-known port. Like the Oracle use the 1521, the DB2 use the 5001 through the something number. MySQL use what number? Do you remember? Why don't you quickly check? I forgot. 226 306. So nowadays each DBMS their port number are considered as well-known port number, which means it's not recommended to use this port number for your application program. Okay. However, you can change. You can change this port number by the server side setting. Okay. So many of the commercial, if the company and site who are using the database, they actually change the port number to be secure. Anyway, so using the TCP/IP and the port number, we can connect the database. At the time, we can use the client software. The only way to access the database is using the SQL. So, but you cannot directly use the SQL. You need to use something, so network, the connection, and something program. So each DBMS provides the application, the program by which you can use the SQL. Like for example, the SQL Plus is Oracle, and MySQL is MySQL, and so on. DB2 is a DB2. Informix and is DB Access, and so on. So some of the people who use one of this, for example, Oracle. I learned the SQL and the relational database using Oracle. But your company used the MySQL. Then you are asking, where is the SQL Plus? I can use the SQL Plus. I never use it. But if you understand such a database concept, that question doesn't make sense. So you can find your own database names, especially the client module. And not much different. They are not standardized, it's not much different because they are using the same SQL. Plus standard SQL plus its own command. DBMS provide their own feature of the command. Then you can just check the DBMS specific feature. Then you are able to use the database. Then, so I will just submit this simple query. Okay. Then during the query process and the query optimizer, we learned what happened when you submit this one. Like the MySQL, the enter, it will be submitted to the server. What happened? The parsing, validating, and scanning, parsing, validating, which means it's a compile, okay? Which is the command line base, so that is the interpreter. So it will be compiled and the intermediate code, or sometimes it's called the P code, intermediate code, it's a compiled code, will be first stored at somewhere in your memory, because there might be chance to be reused later. Think about this is just a rare case. When you submit the query directly by the entering, most of the cases program. So click, click, click. It's the same query will be submitted. So if we keep in the memory, we don't have to process, compile again. Directly use the intermediate code or the binary code. Then the query optimizer use this intermediate code or binary code to find the fastest way to access the data using either cost-based optimizer, rule-based optimizer. Then, when you decide the path, first the database search the memory also. It's called the buffer. In the buffer, it's organized by the database block. So, database also use the block-based I/O. So, when you read one record, I'm going to read just the name of ID 1. Even though you read only one value of the data, but this is here, lead, and other information. But I don't need all the other, but I need the only lead. But entire block will be the copy, transfer. So memory is the same thing. So first check the memory, whether this block is in the memory. Okay, if not, access using the execution plan from the query optimizer. Access the table, employee table, using the full table scan to find the data block, then read the data. Then, if it's not in the memory, copy this lead. Then return the lead to this one. So this is usually what's going on when you select the data. Next time, if you submit this one again, same thing, but it's already in the memory. You don't have to compile again. And also, this data block is also in the memory, and with the next time it will be very fast. Even you may realize the difference when you select the data. The next time is so fast. So, question. So there's a hit ratio. Hit ratio is the number of access from the buffer block over total number of accessed block. This is called the hit ratio. The higher, the better. Definitely the better. Okay? So 100% hit ratio is better, which means 100% from the buffer, not the secondary storage. This is much slow, as you can find from the operating system class. Then, question. What is the recommended hit ratio? So, if you are managing the database system, what is the user recommended hit ratio? Obviously, 100% is not possible, right? You need to read the data from the hard disk drive the first time. But if you manage this database system, what is the recommended the hit ratio? 70%?
80.
80? If you manage your system 70 to 80 hit ratio, you will be fired. Even 90 is not acceptable. Most of the well-managed system is recommended 97, 98% hit ratio, which means 97 out of 100 times most of data from memory. Okay, that is the reason database search is faster. Should be well managed. Then, surprisingly, it's 97 to 98%. How can we keep such a very high ratio? There are some details algorithm. Most popular algorithm to manage the buffer is LRU algorithm. This recently used algorithm. Simple idea. If the block is accessed frequently, and we have the list of the block, then most frequent one top, and layer the bottom. So it's the LRU to the not frequently accessed data. Then that's not enough to keep such a high hit ratio. Idea is the database actually is the same as the I/O system. There is an 80-20 rule, which means most access data is only 20%. Idea is why don't we keep this data in the memory? Also, you can specify when you create the table, you can specify the characteristic of the table that will be in the memory. For example, when you design the database, so this is the employee. So there are department and work zone and something other table, like the location. Okay, this is a user. Why? This is a main table, but during the normalization or segmentation, we have a lot of small tables. These are not much changing. Okay, and this is, so why don't we keep such a small table? Sometimes it's called a lookup table, or sometimes it's a code table. And one is the HR, two is the payroll. So such a small table but frequent access, you can keep such a table in the memory. Then you can get the high ratio, hit ratio. So it's a 97, 98% of them from the memory. Okay. Then another thing is we have the column A, value 0. Column A, so this is the test table. So update the A. So we'd like to update the value A into 1. Okay? What happened? Same thing happened as the slide. It should be compiled. The scanning, validating, parsing and validating, and create the P code and intermediate code and stored in the memory. If that is in the memory, you can reuse. Otherwise, you need to do such a compiling process. After compiling, another thing is you need to process query optimizing again. Not again, you need to apply the same query optimization to the update. Delete. What else? Update, delete, insert. Why? You need to find the location to update, to delete, to insert, which means you need to find the fastest way. You need to apply either RBO or CBO query optimization. It's the same as. So this is one common mistake. The query optimizer is only for the select. No. Select any query need a query optimization. So sometimes your update is very slow. It's update only few record, but very slow because it takes long time to find that data. So at that time you can apply the query optimization. So after applying the query optimization of the test, so this will be updated. Okay? Then what happens when you update? First, same thing, check whether there exists 8 here or not. Okay? In the buffer. If not, then we read the data and copy this block as a 0. Okay? And then we need to update. How do we update? Like this one? The problem is if you update the 1, it's not returned there, it's updated. The next time, almost the same time, but right after this one, there's another user, MySQL, select A from test. What will be returned? 0 or 1? 0, 1, which one? When this one try to read, going to the here, if there is the value in the memory, it will return this one. So it will be 1. That's the problem. It's not consistent because, as we discussed last time, should be isolated. Okay. So to address that problem, database create 0 and 1 when you update. So 0 is the old image, and 1 is new image. Okay. This one is called dirty buffer. Dirty buffer means changed one. Okay? It's a changed the buffer. This one is a dirty buffer. Then, what if there is another process to the update? Then you can create another version of the buffer. This is called the multi-version concurrency control. You can concurrently allow to access the same data with what? Multi-version of the buffer. So this is before image. This is after image, old image, new image. What? This is called the, if buffer is changed, it's a dirty buffer. Then, this time, if you try to read the data while it's updated, going to this, and which one? Old version will be returned. So 0 will be returned. But this time, enter, then commit. When you commit, after commit, which one will be returned? 0 or 1?
1.
After commit, this commit means what?
Successful completion.
Permanently apply. Permanently. So system, one of the characteristics of the system is ACID. C is the consistency. Consistent means one state to another state. Because the commit means end of transaction, so it will be permanently applied. So this time 1 it will be returned. Another question. After commit, this 0 will be removed right away. Yes or no? True or false? True? False? Do we need this old image after commit? Even though commit, we need this old image. Why? For example, if this one is running before commit, like the select, it takes a long time. Okay, you have a lot of data. So even though commit, this query should be based on this time. So until this process is completed, we don't know when it's ended, but we keep the old image also. But version is old one, but this is a timestamp, the noon, the 12 o'clock. This one is 1 o'clock. So this time it starts the 12 o'clock, but it's committed at 1 o'clock. But because of currently it's 2 o'clock, but still running, the image of this query should be based on 12 o'clock. Because of that, still keep in the memory. Even though that is the old version, committed. Okay? But if this query starts after commit, then we don't need. We read this data. Okay. Another question. So this is updating all the value. Like the test has 10 millions of data to update. Takes a long time. So for each block, we need to before and after image. Before and after, before and after, before and after, before and after, before and. What if it is full of the memory? Full of the memory. We cannot keep all of this. At that time, we are updating, even though not committed, we update the hard disk drive. Even though this is not committed. Okay? Then this time, it's not committed yet. There is another process to access this data. If you go to the here, so there's no, the A. So going to hard disk drive, it's 1. So return 1 or 0. It's supposed to be 0 because it's not commit. Still running, but it's update the hard disk drive permanently. To address that problem, so do you remember, we are going to keep the rollback segment in the permanent storage. That is a before image, after image, temporarily. Okay, so all the before and after image will be stored at the only before and after image, not block by block. Okay, block is too big. So only before and after value will be stored at the secondary permanent storage. So in this case, so this one is 1, but this is the time based on the 1 o'clock. So still running. But I need the old version because it's not committed. Old version, there's no old version, it's not synchronous matching. So we can go to this one, RBS. Then what is the old value of the A? 1, this is a 0, and go to this. This is one of the data structure used in the database management system to keep the consistency. So many of the people do not know the importance of this one, rollback segment. This is a kind of the permanent storage of the buffer. However, buffer keep the same structure as the database file, blocking. But this one has only before and after image. So this will be used for the consistency. Okay, another thing is, another question. After commit, like this is 0 and this is 1, and after commit, what about this value in the hard disk drive? Is it 0 or 1? Supposed to be 1. However, right after commit, it's still 0. At this time, any other transition who would like to read the A, just read this data from the memory. Why? This is not the 1. It's still 0 in the secondary storage. If you write the 1 to here, it requires I/O. Takes a long time. So we delay the writing. When system is not busy, we can flush out all the committed data to the hard disk drive. This is called the deferred writing. So deferred writing is not only for the database, your operating system use the deferred writing. Because always accessing the secondary permanent storage takes a longer time. So I gave the example of the USB hard disk drive. So Windows suggests to safely remove always. Why? You are changing the information in the always memory. From time to time, flush down. So if you change the file of the USB drive, then right after that, if you unplug, you may lose. But sometimes, even though you do not push the safe remove button, you still keep. The reason is that if your unplug is after the synchronization, first then it will be okay otherwise. So it's the same thing in the database. So it's based on the deferred writing for better performance. Okay, then it will be changed. Then another question. So right now, 0, 1 committed. So, and still this is the 0. When you access the A slide, what will be the return value? It's a 1. It's a committed. Because it's committed, it will be returned from here. Okay, no problem. The problem is we have power outlet. So unplug the power. What happens when you unplug the power? You lose all of this, especially memory. You lose this information. Then you realize that you unplug accidentally and plug in again. What happens when you try to read the same data? So you do not have this. It's only in the hard disk drive. What is the value? 0 or 1? It's a 0. You do not have 1. So which means it's inconsistent. So it's a problem. So to address that problem, we are going to manage another one in the secondary storage, that is a log or journal. Log, whenever just before last action of the commit is the log update A to 1, 0 to 1. This is the last action of the commit. If you cannot write this one, you cannot commit. So this one is also buffer. There's a log buffer for speed up, but this one during the commit always the write in the log data. Then how can we use this? This is called write ahead log. So logging this command to the secondary. It should be permanent storage, persistent storage. So then what happens? So when you plug your system, check your data with the log. This one's supposed to be what? 1. But it's a 0. It should be 1. But it's a 0 because it's default writing. Couldn't happen. At that time, check the log whether this timestamp update 0 to 1, which means supposed to be 1. So you can apply this into 1. This is called, you can do one more time the update because of this. So this is called the redo operation. So redo is it's supposed to be applied, but it's not applied because of the default writing. So using the log, you can recover such a transaction. Okay? So this is called instance recovered. Instance recovered. Even though you do not mention to restore the recovered system, but instantly it's a recovered system.